Q13b part 2 is telling us that Io has several active volcanoes on its surface. One of these volcanoes produces jets of sulphur with a velocity of 1.3 kilometers per second that rise 470 kilometers above the volcano. And it's asking us to calculate the constant acceleration of freefall on the surface of Io. The fact that it's telling us it's a constant acceleration means that we can use our Suvat equations, so S, U, V, A and T, and just as a little point, it's asking for the acceleration and it wants it in meters per second squared. So let's have a look. What do we know? Well, the displacement, well, it's telling us that it's shooting them up 470 kilometers, but we need that to be in meters, so if we multiply that by 10 to the 3 we get that. It gives us the initial velocity as being 1.3 kilometers per second. So again, we need that to be in meters per second, so let's multiply it by 1,000. When it's at its height, the velocity will be equal to 0, and it's after the acceleration, which is what we don't know, and we know nothing about the time. So we need to find ourselves an equation from our formula sheets that doesn't have time. So that one is v squared equals u squared plus 2as. And because the initial velocity is going to be up and the acceleration back towards the planet's surface or the moon's surface is down, we could write this out as being v squared equals u squared minus 2as, because the acceleration is in the opposite direction. We know that v is 0, so v squared is 0, so 0 equals u squared minus 2as, and I can write that out to give me 2as equals u squared. Therefore the acceleration will equal u squared over 2s. Now once we've manipulated this into the form where we've got the acceleration as what we want, we can substitute our values in. U is 1.3 times 10 to the 3 meters per second, and we have to square that. If we divide that by 2 times by the displacement, which is 470 times 10 to the 3, and put those numbers into your calculator, and you should come out with an answer of being 1.8 meters per second squared.